ConOps applies to any engineering project, and it's good practice to do that. So what to expect today in this morning's talk, or this afternoon's talk, is the purpose and concept of operations, what it is and what it is not. And by the way, the federal FHWA stands for the Federal Highway Administration, which is a division of the U.S. Department of Transportation. They have a life cycle depiction graphic that is often referred to as a FHWA-V, and I'll be talking about that a little bit later. And I'll talk about the origins of the ConOps as far as I could research it, talk about industry standards for ConOps, and then I'll present a brief template with notes on how to write a ConOps that you can use if you wish, and then I'll give you references that you can go research. Here are a couple of official definitions of what a ConOps is. The first one is kind of lengthy, and it comes from INCOSE, from their System Engineering Handbook. The second one is a little more succinct, and it answers the who, what, when, where, why, and how for any new or existing system, which I think is a very good description. And that came from the Federal Highway on that reference I have at the bottom. And I'm not going to read the slides to everybody. I'll just point out what I think are the important parts of it, and you can read the slides on your own. And then I'm sure you can get hard copies of this presentation too. The major goals of a concept of operations, and this is taken from another guide written in 2005 about transportation management systems. And I think what's important is to first discover who your stakeholders are in the project, noting that they may not be who your client thinks they are, and they may all not share the same vision for the system. Further, stakeholders may not even know there are others who care about the system and have different views of it. So it's very important that you ask stakeholders when you meet with them and talk with them about who they think would use the system or have an interest in the system. And then you get into a very high-level definition of the system. And the ConOps serves as a foundation for the lower-level system description because stakeholder, also known as user, stakeholder user needs, is established early in the system engineering process, and you understand what people think they want. You develop that into a concept of operations, and that will lead to functional requirements. Functional requirements, as you will see in the life cycle, especially in the FHWA-V, that it leads to detailed design in the actual system itself, and then it goes up into the testing of the system and validation and verification. And there are user classes and user activities, and they're different, and each one views the system differently. So your ConOps has to do all of that. I can hear somebody not quite on mute, but that's not disturbing me. So why is the ConOps important? Well, it's really about communications. Here's an example of a couple who want a house built, and the builder is saying he wants to build a home for you. Well, the gentleman has one idea of what he would like. Well, the other one is a little more practical and has a different idea. So the ConOps is all about communications and managing expectations. That's why the ConOps is not just something you write and put on the shelf, but it's something that lives throughout the project and actually goes beyond that, as you'll see a little later on, that when a project's been underway for quite a while, you may want to revisit the ConOps because things change. So system engineering encompasses the entire life cycle of a system. Now, here are the 7 stages of a system life cycle as defined by the INCOSE Systems Handbook, and also the standard that the System Engineering Handbook is based on, the ISO IEC 15288 in section 5.2.1. You see this. And there's the exploratory research, and then you develop the concept, and then a development of it, production, you use it, you support it, and then you retire it. That's the entire life cycle. we'll talk about the concept today, stage 2. Now here's the Federal Highway V diagram that I've mentioned before, and you can find it in the System Engineering Guidebook for ITS, which I'll give you another reference in a minute. But what I did was I mapped the life cycle stages from the previous slide onto this so you can see where they line up. And the Federal Highway talks about this as phases. And where we fit in, well, first of all, you start off with a regional architecture in the Intelligent Transportation Systems. You talk about regional architectures of systems and how they work together. You explore different concepts, and then you write a system engineering management plan called a SEMP on how you're going to manage the system process. And then at that point, we get into the concept of operations, where you start firming things up and build the basis for the system functional and performance requirements. And that will lead eventually to high-level design, detailed design, build, unit testing, integration, testing, and finally, verification and validation, operations, maintenance, and finally retirement. So that's the entire thing, and there are control gates throughout the process where you verify that you've completed all the necessary steps. Again, we're only going to talk about the concept of operations. What's the ConOps used for? It is used for many different things, and it provides a vision for everybody. So everybody has a common vision about what's being built, and it's important that everybody work together and have the same vision, or else there'll be a lot of conflicts. The identification of system stakeholders. It's a formulation of high-level system definition and establishes lower subsystem descriptions, and it talks about the environment in which the system will function. Environment, not only physical environment, but also the people who use it and how they work with each other. As far as I could tell, the ConOps originated fairly recently. The AIAA stands for American Institute of Aeronautics and Astronautics. In about 1992, you started seeing work by them for a concept of operations document. The Department of Defense developed the operational concept description document, which is quite similar as a data item description in their regulations in 1994, but they didn't provide too much information on how you use it. The current guide to operational documents is published by the IEEE and by ISO. It's 14711 and ANSI ConOps G043 1993. Those numbers. I'll go into a little bit about what the standards are. This is the cover of the System Engineering Guidebook put out by the Federal Highway and the California Department of Transportation, which has been adopted pretty much as a standard for them. And it applies the system engineering principles to intelligent transportation system projects. They refer in this document, they refer to those two standards that refer the reader to further information on how to write a ConOps, and I put that on there and underlined it.
Hi, John. Sorry to interrupt. I'm just going to re-mute everybody because I think people that joined after me muting are not muted, and it's getting quite distracting, the background noise. So if you don't mind, I'll just do that again, and then you can carry on happily.
I'll do a star 6 again?
Yeah, that'd be great. We'll just try and do that now.
It's also for management.
We've got quite a lot of noise coming.
And here we go again. The G043 1992 is under revision by INCOSE in 2011. I don't know that it's been published officially yet. So I thought I'd compare the two standards for you. And the one on the left is the 1362 standard, and the one on the right is the, well, actually, this is the name of the new standard. It's going to replace the ANSI IAA G43. BSR, I think, stands for Board of Standards Review, and I imagine when the standard is adopted fully, the BSR part will go away and it'll just be an AIAA. So I started looking at the two, and they're actually pretty similar in that Section 4 of the 1362 is actually Section 6, and the important part for me, the operational scenarios, is Appendix B. So they're quite similar. However, being a systems engineer, I could not help to do a detailed color-coded eye chart to highlight the common parts of the two standards. I don't expect anybody really to read it, but the one on the left and the one right next to it, those are the two different standards, and the colors show the similar sections. So what major differences? 1362 lays out why and what will be in those different sections. And I found that the old standard, the GO43, is more like oriented towards military. It's probably one of the original ones. And it's linked very closely to the Department of Defense Standard 2167, which is not the way most commercial projects are developed. So as we get into intelligent transportation systems, which are commercial products, and you work with commercial vendors, they really don't understand the different standards the U.S. government uses and the DoD. Now, the revision that's coming out borrows from the 1362 and produces a more current, easier-to-use standard. So I suspect when it's released officially, that'll probably be the one to use. However, I think one of the more important parts of the ConOps, and the hardest part to write for most people, and it's often skipped too, is the justification for the new system. Why are you doing a new system, or why are you revising an old system? So I thought I'd go through this justification and nature of changes. On the left is the 1362, and on the right is the new standard coming out. And they're essentially the same, so I'll just go in on the left one here. And justification for changes. What changed in the user needs and mission objectives that require a new system? And then you list the deficiencies or limitations of the current system and justify the new system. Why you're doing it. It improves, what you do. Basically, you explain why it's needed. And then you describe what's being changed, what new functions you get, how it changes the environment, what changes that are needed to support the new system, because sometimes when you bring a new system in, you have to change the way everybody operates, or it will change how everybody operates, and they need to be aware of that before they get the new system, or else there'll be a lot of chaos. What are the priorities among the different changes? They're not all equal, and sometimes you have to decide as you're building the system to not implement certain parts of it and postpone that till later, or that you don't have enough funding for it. So you've got to prioritize the changes. What are the most important? And you're getting this information from your stakeholders. And what changes did you consider but you didn't include? There might be some, like one or two stakeholders out of 100 wanted something and it just didn't make sense because nobody else did. Whatever. You need to discuss what you thought of and what wasn't included. And you got to give a reasonable reason. And what assumptions and constraints are there in the system that you're going to build? What assumptions did you make? You can include schedule and budget constraints on the new system as part of this if you want. Now, I recommend personally using a tailored version of the 1362 standard right now. It's more recent than the older one, and it seems easier to follow. But I think if you apply the entire standard to a project, it'll be overkill for most small to medium-sized projects, especially in the business field that we work in, the intelligent transportation systems. And also, ConOps takes a lot of time to write and a lot of effort, and it gets expensive. And it's not always the most cost-effective for most ITS projects to do a full-blown ConOps. Most of the clients, by the way, are interested in only a few key parts of it anyway. So I think the primary use of a ConOps for ITS is to establish stakeholder consensus and a common vision for the future system. And that's where I found it to be very, very useful, in that I go out and listen to the stakeholders, record what they want, and then interpret that into a fictional system, a hypothetical system, and I write about it, and I write about how it would work. And then the stakeholders read about it, and they say, wow, this is great. This is what I was thinking, or, boy, I don't know what this is. I didn't even think I wanted this, or I don't want this at all. It's important that the ConOps get a lot of feedback, and if you write a ConOps and then you have a concept review with the stakeholders, like a workshop. And if everybody's quiet during the ConOps review, you have failed miserably. You have to have a very interactive, spirited discussion among the stakeholders and let them work out among themselves what it is that they all will agree on and what they want the system to do. And the other thing about ConOps is that when you get it all done, you can write an executive summary that is 1 or 2 pages, and it can become a very effective outreach tool for the public, and it explains the system very succinctly and what's coming. So it's a very powerful tool to use to manage expectations. Here's what I think the minimum ConOps content can be. You have the introduction part where you're setting the stage for the system. And then you add some applicable references, but only for the sources that are mentioned in the document. You don't throw references in there for things that aren't referenced in your document. And then you talk about what the current system or situation is, why you want to change it, describe the new system in a functional architecture description, and that gets into another lecture about how you do system definition and their different techniques and things like that I can't get into right now. And what are the advantages and disadvantages of the new system? And then talk about operational scenarios from the different users' viewpoints. And users are people who use the system, people who operate the system, people who manage the system, and people who manage the people managing the system, all different aspects. And what I like to do is I take a scenario and then describe the same situation from different viewpoints of people that are using the system and interacting with it. Then you add notes, glossary, and any supplemental material. Now, my personal preference is to add a couple of more things to this, which is a rough order of magnitude cost estimate, called a ROM, and a schedule with an expected critical path. And I do this because we're talking about a system that we're going to eventually build. It's going to become real. And I want the client and the stakeholders to have a sense for what it might cost, because sometimes it might be more expensive than they want, and you might have to refine it and trim it down. And then I also add a project sequence where, okay, we've got the ConOps, what are the next things that you're going to do to realize the system? So tips and techniques for good ConOps, and this all comes from the Federal Highway. I didn't make this up. And most importantly, get your stakeholder involvement early and often. Include the users as well as owners. And in my case, when I'm doing advanced transportation management systems, which is command and control for the highways, for the different state DOTs, I like to get the actual operators that operate the software in early on and get their feedback and get their opinions, because eventually they'll be taking the software and using it. So it's important to get their buy-in early. People hate change, so the earlier you can get them involved in owning the change, the better you are. And it takes time for the stakeholders to get involved. And remember, they all have day jobs. They don't have the luxury of spending hours and hours and hours working on your pet project because you're interested in it. They would prefer that you just go away and bring them back exactly what they want, but it doesn't work that way. You need the ongoing feedback. And system engineering process is built to do that with those control gates, and you're basically in their face. I have a graph that I don't show here in this presentation called the chaos graph. And if you follow the system engineering process, chaos is defined as uncertainty and stress. And it starts out as you get into asking all these questions people don't know the answers to, they get very stressed. And then as you go through the system engineering process, you come back down off the peak, but then you get to the next stage of detailed design and it goes back up again, but not as high. And it continues that process until it damps out and you deliver a system that has no surprises and people know exactly what they're getting and it works. Update the ConOps as systems change. It's, like I said, you don't put it on the shelf. It's a living document that needs to be updated when things change. That's what they talk about. There's a life expectancy of most systems, and it's what, depending on the business you're in, it's roughly around 7 years, I think. And it changes. I have another discussion, another presentation that talks about software failure. And software breaks down just like mechanical things break down, and it breaks down not because the software bits fall off the table or something like that. It's because things change around it. The environment changes, the users change, they want to use the software in a different way that was not built to do, and eventually it won't do it anymore, and you've got to build a new system. And that's why software breaks. Write simply and use diagrams and pictures to convey the concept. It's very important, at least from my viewpoint, that you use diagrams and pictures, and pictures worth 1,000 words. Well, I think that's really true. And it's a guiding vision as you move through the system lifecycle. So, it's easy to lose track of what you want to accomplish overall. But no matter what stage of system development, go back to your ConOps, update it, and circulate it, and it helps keep everybody what it is they intended to do. I've got a project here in the United States that is a transportation management system project that started 7 years ago with a concept of operations, and we're finally getting a vendor on board now who's building it. And it helps to go back and read the original ConOps to see what it is that we originally wanted to do. And then it has been revised over the years to adjust, but it's still pretty good document and keeps everybody focused on where we're going. Do you need it for an existing system or just a new one? Well, you actually do look at existing systems and you think about how things have changed, and you might want to change you might want to write a ConOps just to examine whether you need to modify the system or build a new system or what. But remember, developing a ConOps for an existing system puts a strain on the human resources, and the developer of the ConOps may embarrass the client. You may uncover something that they knew but they didn't want to say. That demonstrates an inadequacy of the existing system, and it may not be opportune for the client to bring that out. So there's some things you've got to be sensitive to. Now, as promised, here's a template. This is based on one of the standards, and you start with the introduction, and then you identify the official identification for the project and abbreviation if there is one. Provide an overview of the document, and then provide a brief overview of the system. So the section 1 is basically almost your executive summary. High-level graphical overview of the system is strongly recommended. You can do a physical layout diagram, a top-level functional block diagram, other diagrams that kind of depict the system in its environment and how it works. High-level, big picture. Section 2, applicable documentation. Only like to put in the references that are used in the document itself. Then you describe the current system and situation, what kind of operational constraints exist today, and describe the current system in detail. And talk about who the different users of the system are. what kind of support environment it needs. Then now that you've talked about what exists, then you talk about why you're changing it. And I've covered that already. And then you get into Section 5, which is concepts for the proposed systems. And you go back and describe what it is that you want to do, why you want to do it, what kind of policies and constraints exist today and could exist in the future. Describe the proposed system. Talk about the different modes of operations. Talk about how users can get involved and interact with it. What kind of support environment it's going to create. You could run into a situation where you describe the ideal system everybody wants, but the support environment for it is prohibitively expensive. And then operational scenarios, and I like to get into making them interesting. By interesting, I mean something that's easy to read. You don't get into a lot of technical detail such that only engineers could read it. You write it so that the common person can understand it. And the whole ConOps should really be written at a level that other people can read, find it interesting, and understand it. Then you write a summary of impacts. So if you build the system, what impacts will there be in the environment, in the people, in the users, the operational? You summarize it there. And then you provide a detailed analysis. And my personal preference, again, is to do the rough order of magnitude cost and schedule based on months after contract award, just to get some feel for what it is going to take to do this. Notes, appendices, and glossary, that was pretty standard. So recommended reading. If you want to get into more detail and understand what this is, here's some good references. The IEEE standard, fortunately it's not free. You have to purchase it. There's the new one coming out. There's the draft available at that. And these URLs were good as of a couple months ago. I didn't try them recently. But there are some very good handbooks and information here that you could read. And are there any questions? Need any help? You can contact me. Just remember, I'm over here in California, so there is a time zone difference in different parts of the world, and I usually don't start work till about 8 o'clock in the morning over here, today being an exception. So I turn it over to Rayan and whoever has any questions.
Hi, John. Thank you very much for that very interesting and insightful talk. It was really great. I think we'll probably have questions for that. I see we've got one already in the Q&A section. Could everyone make sure that their microphones are muted? We've tried to do it from this end, but I believe that the last people to join, their microphones aren't muted. So just to cut out background noise for this last section. So, John, I don't know if you see that question from Chris Bouch.
I do. I'll read it.
Yes, okay, I'll leave it to you.
Yeah, when building the ConOps, to what extent have you found user high-level policy documents to be an acceptable source of high-level requirements instead of relying on face-to-face meetings with users themselves? My personal preference is face-to-face with the users. You can't replace the face-to-face. High-level policy documents have a place. They are constraints, really, and it's actually you have to talk to the people who would use the system and have a stake in it. From Brian, we have, who is responsible for maintaining and updating the concept document on a large project? System engineer. Hopefully every project has a chief system engineer, and that is somebody who works for the project manager, but who is responsible for the technical execution of the system and who is usually the one who either wrote the SEMP or runs a project in the way the SEMP describes. I see Warren has entered. I know Warren from many years ago. Q&A. Nigel has a question. How do you think the FHWA requirements for system engineering may be used by other DOT agencies? Well, I think the requirements for system engineering, I think system engineering should be applied to all projects, of course, being a system engineer and speaking to an INCOSE group. But it's just basically good common sense. I mean, I often go to clients, and one of the first things I do in starting a project is I go through a short 1 to 2 hour description of the system engineering process, and 9 times out of 10 I get done and they say, well, heck, that just makes common sense, is what I usually get. And it is. It's just common sense. You ask people what they want, you document it, get them to agree, and then you build it. And the trick is, I guess a lot of you engineers know, is that once you baseline the requirements, what will drive the cost and schedule crazy is if they start changing it as you go along. So that's why there are baselines as you go through the life cycle and you complete something and then talk about change. So system engineering in project management in itself is all about managing change. Warren, do you recommend including a list of user needs derived from operational scenarios in the ConOps? Yes, I do. I think that's a good idea. These are great questions. I appreciate them. Jochen, are there similar standards, good practices for maintenance concepts, which I think often complement the ConOps? I don't know the answer to that. I don't know. I'm sure there are, actually. I'm thinking of operational and maintenance, O&M manuals and plans and things like that, and I'm sure there are, but I just don't seem to know them right now. And while it may seem to be common sense, it's not common in transportation. Many agencies are reluctant to spend the time in planning stage to focus on a structured ConOps process. That leads me to another slide that I don't have. It talks about the value of the system engineering process. And studies have shown that if you spend more time in the early stage planning and defining the project, that you save money and time in the long run. And it's primarily, I've got another one that shows the graph of the cost to make change in a project, and it's cheap to make changes in the early parts of a project when all you're changing is paper. When you get towards the end, you've built product, and to make a change when you have a built product, you've got to go back and change the drawings, change all sorts of things, and remanufacture it. So it's a lot cheaper to write it all down before you do it. And the other thing I found as an engineer and managing engineers is, and I do it myself, is that I can think of solutions in my head that are elegant, but when I try to write them down, it's very difficult to actually make sense of it. So by having engineers write things down, how they're designed, how things are going to work, you find a lot of problems early on.
Are there any other questions? I know you're not able to speak.
There's a question here that just popped up. We also find that if tailor and structure effort to scale to the needs of the project, complexity of scope very much helps the business case. We've done 5-week ConOps and performed 5-month ConOps. You're right. Some projects that I get involved in that are very small have something like a 5-10-page ConOps, but it's helpful to do that. Another question from Tom Hughes is, we have a consultant coming on board at the end of the project to develop the ConOps. What should their approach be in capturing the upfront planning that they missed? What should be their approach in capturing the upfront planning that they missed? Well, you really have to identify the stakeholders and get them to express their user needs. And by the way, when you talk to stakeholders like operators of a system or maintainers of a system, you'll find that they view the system in a very low-level, detailed way. And some of their user needs are so detailed that you have to actually translate them back up to a system-level function to make sense of it all. So, I like waterfall method of parent-child relationships and requirements. And I'll get these little detailed things like this widget has to fit here, and I got to think, well, is that a function or is that, a physical thing? And what is the function that's being performed? And I got to translate that. I don't know if that answered the question, however. Mr. Wong, what % of a project's resources should be developed by ConOps? Do you have a heuristic? No, I don't. Overall, I think like 35% of the project effort should go into the upfront specification, ConOps, that kind of thing before you actually build anything. But I usually find, now I'm just throwing a number out that I use, is around 80 hours for ConOps for the kind of projects I do, which are $1 million or so. And I find that usually works. Anything else? We got Larry Johnson's asking a question. When revisiting the ConOps throughout the project, is that done by tracing changes to the detailed functional requirements back through to the high-level requirements, eventually back to the ConOps? How critical is traceability of detailed requirements to the ConOps and vice versa? What I do is I trace user needs, or stakeholder needs, and I document those, and I give them. I have a requirements database that I use, and I said I use the waterfall method, and I give those all the letter A. So I number them A001 through however many there are, and then I take those and I develop high-level system functional functions. And I use the black box approach. So I take one big black box and I say, this is the system. What goes into it? What comes out of it? What does it have to do? What needs to support it? And this is actually called HIPO, Hierarchical Input Process Output, or also known as IDEF, which is a version of that, very similar. And I go through a method of taking the black box and making smaller black boxes within it, and each one results in different sets of functional requirements. And I number the requirements as the letter S for system-level functions, and then I go into subsystems, and those have 2 letters which define what the function is, and goes on down like that. It's a whole complex thing, and I put it in the database, and life is easy when I can use a database to manage all this, and then I can use traceability. So I can trace things all the way. And then you can also trace outside standards like the federal 1209 or whatever it is, do your things. Colin Wood, do you ever model your ConOps in the sense of getting some consistency into the documentation? That's a good point. I think if you have a good ConOps, that you're building a foundation for the documents to follow. And I do like to use standards. When I was doing the Department of Defense work, the government was very happy to give me what they called DIDs, data item descriptions, which are very detailed templates on how to write the different documents so you don't leave anything out. And I have a whole list of templates that I use just to be consistent. And I think everybody on a project, in the SEMP, you should identify the documents you're going to write for the project and then provide templates that they can use so there's some standardization. Wow, we're getting some great questions here. I thank all of you for taking the time. Andrew, in your experience, to what extent have you been able to take advantage of and manage reuse and standardization in ConOps document? If a system has an existing ConOps, I'm going to write something for a system that's going to replace it. Some of the background material is good in there. Other projects with similar functions, you can use that, some of the boilerplate from that ConOps. So, yeah, you can reuse, and it helps a lot. And 80 hours is very low relative to our experience. Planning phase for transfer should be approximately 5 to 7% of the project cost. Yeah, I agree. I'm just talking about actually writing the ConOps, not other parts that go along with it. So, yeah, you're right. There's a lot more to it. And there's also trade studies, cost-benefit studies, things like that that also go into building it up, and that's beyond that 80 hours I was talking about as well. I'm just talking about once you know what people want, sitting down and writing a ConOps. From Nigel again, how should non-system requirements such as safety operability be managed? Well, I get that a lot. There's two parts to a system, what I call a request for proposal, RFP. And, well, there's three parts really, but one part is the system functional specification where you say what the system has to do, and then the scope of work or statement of work, which is what the contractor has to do, not the system but the contractor. And then the third part is the terms and conditions that are contractual. A lot of people, not a lot of people, but I've seen mixing up of the functional system requirements with what the contractor has to do, and it gets to be a very confusing document if you do that. I like to keep them distinctly separate. And operability is a requirement of the system. Safety is a requirement of the system. The part that the system can affect. So you think of the system as a system that does certain things and how you do it. And let's see, Colin, I was actually thinking of building models, say UML, from which you can generate the ConOps rather than document template. Yeah, I have UML and UML2 that I've used on projects. I've actually written a ConOps with UML diagrams, and it's very doable. UML is a universal modeling language. Really lends itself to object-oriented software and object-oriented programming, in my mind anyway. And so it's good for that, but if you get outside of that realm, it can be confusing to a lot of the clients. And I don't know that I have any more. We may have worn everybody out.
There's some great questions there. Lots of questions.
Yeah, great. I really appreciate it.
Yeah, thank you everybody for your contributions as well. It's really great.
Email me if you have more questions and want to open up a dialogue, or if you need some advice. I'm always happy to give advice.
Okay, thank you, John. If we were in a real presentation now, you would have got a big round of applause that everybody's muted. So
right. Thank you very much.
A round of applause from everybody. Hopefully this has been recorded if everything worked as planned. So we will be able to give access to people who couldn't make it or didn't manage to get in on this call. I'll check afterwards that everything worked and send that out. We're also trying to schedule this to cater for the Australia time zone as well. So there may be another opportunity to watch and participate in this webinar. Thank you very much, John.
My pleasure. Again, thank you, everybody, and thank you for the opportunity. I appreciate it.
Okay, and thank you, everybody, and please do get in touch if you have any suggestions for the next webinar.
I have a question. Will you distribute the slides?
Yes. If you're happy with that, John, we can distribute the slides.
Fine. You want me to send it to you, or do you have it by...
Yes, you could send me the latest version, and I'll... Okay, great, and then we can distribute them if you're happy with that.
Okay. Thanks, everybody.
Great. Okay, thank you all for joining, and we'll see you at the next one.
I'll go have breakfast.
Okay, thank you, John. Have a nice day. Bye.